Okay, everybody, this is part 2. If you have not watched the previous video on NovaServos file, please do. Just to recap, this file contains a configuration and variables and arrays for basically moving the servos that the class is going to refer to. And in this video, I'm going to review that motor class. And as a side note, I found a little bug in the Arduino IDE. So in my last video, I was in this file showing it off, and I have also the main program file open. And while I was in here, I did a little zoom so that you guys could see the code a little better. But check this out. Then when I went back to my other file, I panicked. Look at that mess. Gotta love Java, right? I can't stand Java program, and I can't stand Java machines and virtual machines, and there you go. Anyhow, it's, not a devastating bug. I thought it ruined my file at first until I realized it's a display thing. But yeah, everybody, please stop with the Java already. Thank you. Okay, that's just me as a 25-year-old web developer veteran giving my 2 cents. Okay, I wasted enough of your time. Moving on. So let's get through all of these variables here and come down to our class. So in the main software, we have this async servo class, okay? And what this does is it will instantiate an object. You can see here I have the class collapsed, but right below it, right after it's created, I instantiate the objects. So each servo has an instantiation of that class, okay? So we create an object for each servo motor. And then we pass the controller, a reference to that controller. That's very important. You will not be able to do this if you don't do that. And then we pass it the servo ID. Okay, so we create our 12 objects here from this class. And those are the only 2 parameters, excuse me, that you need to pass in. Now, in this case, yes, in this project, I should say, we're only using one control board. So literally, I could probably just tear this out, this parameter, and make this a whole lot easier. However, this software is kind of an incarnation of my Hexapod project, which had 2 controllers. So in that case, I needed it. So I figured it was best to keep it there. Okay, let's just dive right in so this doesn't become an hour-long video. So here's our class. So the properties of this class of these objects will be A, a reference to the driver, B, the servo ID, C, the name of the driver for the servo. This is again to support multiple, which we're not, multiple boards. The increment unit, which is basically how much to increment the pulse each loop through this class. Because I should say, side note too, this class is fired with a state machine, so it's running constantly, looking for your requests to move a servo. And when it sees that request, it'll fire off the appropriate method. Well, I shouldn't say that. We're firing off the method in the loop down more, which I'll show you after we're done here. So it's constantly monitoring the servos and then using those arrays. When you tell it to move one by setting those arrays for a servo, this will pick it up and take that action. Okay, so anyway, I'm digressing again. I apologize, I tend to do that. As you can tell, my videos are unscripted. So those are the properties of each object. Okay, then we have the method that instantiates it, the constructor. So when I set them up here, you can see this calls the constructor, and we receive the reference to the driver and the servo ID. Okay, and then those get assigned to the properties up top here. And then you can see here I'm pulling out the actual, oh, this is a failed comment. That's what you get for copying and pasting, so I'll fix this later. It's referring now to this is the first time we refer back to this configuration file. Oh, geez, look, the spacing's all screwed up in here now because I zoomed. Oh, wonderful. I haven't tried the new IDE yet, but if it's written in Java now, I'm apprehensible. Yeah, another side note for those of you who don't know, in preferences here, you can actually set this up to use an external editor. I probably should not have done that because it's prompted me to save, so I'm not going to do that. But when you do that, this just gets grayed out and you can't edit it. But then if you open this file in any other program, this is keeping it in sync. So when you click save in that other program, it'll update here. So I have used my other editor. I use Ultra Edit for my programming, and I've connected it to this, but it is kind of a pain in the butt to swap back and forth just to upload. So you still need to use the IDE to connect to Arduino and upload your code. But it is nice to edit it in an actual editor, not this Java stuff. Okay, again, I digress. I promise I won't do that again throughout this video. Okay, so yes, this is the first time we see one of those variables. I'm not going to say it, but it screwed up my spacing in here too. Servo setup is the first one we refer to. And you can see that one's here, and I'm just basically pulling the pin ID out of here. So then we know what pin that servo refers to. Okay, and then the increment unit is something that I don't change, to be honest with you. Again, I did play around with that in my Hexapod project, but for this project, we just leave it at 1 and go with that. We control the speed by the time delay in the servo itself. So that increment doesn't change. Let's just make sure that's true. Yeah. Sometimes I forget. I'm getting old. Okay, and then we have our last update time, which obviously is used for the state machines. I'm sure most of you are familiar with that. If not, you're going to get familiar with state machines using this software. I think I've mentioned before that I fire off 6 or 7 or more. All right, so that's how we instantiate our servo. Okay, and then we only have one other method in here, which is called update, and that controls 2 things. Okay, it controls servos that you just want to move, and then servos that you are sweeping. So that one's moving, and this one's sweeping. Okay, so there is 2 sections within this one update method. So we'll go through them both. The sweeping one I'll probably be pretty brief about. Okay, so the first thing, this is running constantly. If we look down into our loop, you can see right here, the first thing in the loop is, yes, we're firing off that update command for all 12 of our servo objects in this case. That's why now it's prefixed with an S underscore. That was just my convention. That's not a coding thing. Okay, so yes, the first thing it does, it says if the active servo array for that ID says that it's active, then okay, it knows it needs to run it. Okay, then the first thing it does is this is to catch the end of the loop. When it goes through its complete movement and gets back to this loop again, it checks to see, oh, okay, are we at our target servo position yet? Is the current position at the target position? If so, then it sets active to 0 and it's finished. Okay? And then it does the time check here, which, again, the state machine for each servo is basically running at the speed of the servo, whatever you set that to. So that really is what determines the speed. So it's a slightly odd concept to grasp, but you will really quick. Just think of this speed as time, and you should be okay. All right, so it's checking if the state machine is ready to run again, if that time has passed, aka the speed has passed. And if so, then it's going to update it because it's about to run through it. Okay, the first thing it does is interpolates the servo ramp settings. So this is probably a video in itself, so I'm not going to run through what this does right here. But basically, it's checking where the servo is at in its path, I guess, start and end, and if it should be ramping, if it should adjust the speed for that step, if it's done, if it's going back to ramping the other way, etc. So it basically just checks where the servo is at in its path and then adjusts the ramping accordingly, and also updates the ramp array so that it can count down and know when it's done, etc. So that's enough said for that section right there, because again, that's optional. If you don't instantiate the servo ramp array for your servo, it's not going to ramp anyway, and that piece of code will just get skipped over. Okay, then I just do a little debug statement here that just prints out the current position and its target and all that fun stuff. Okay, and now here is what controls the actual movement of a servo. So the first thing it does is checks the delay array, because again, I mentioned this in the previous video reviewing the setup file, that you can, if you're going to move 4 servos and you set them each up to move and then set them all to active, they're all going to move at the same time. Okay, but if you want to sequence them, say you want 1 and 3 to move, halfway through 2 and 4 or a delayed amount, you can do that using this array. So you would set a delay for a certain servo and it still iterate through its state machine, but each time it'll skip this delay and tick this delay down. So when delay hits 0, then it will fire. So it's a way of delaying a sequenced pattern of active servos. Okay, and then you'll see a lot of this limit target by min and max. I have a function that I wrote that will replace this, that basically does the same thing. It's just making sure that you're not asking the servo to go somewhere that's beyond its limits. And if it is, it'll reset the target position to that limit. Okay, so that piece we can skip. It's a pretty basic check. And then this here basically does the move. So it's going to check the current position is less than the target position. Then okay, it's going to increment that position, the current position, and move to that current position. Okay, and it does this check here, the greater than, less than, because again, left legs go the other way. So you'll see a lot of that. I've seen in code that some guys do it a different way, using the absolute value of numbers, which basically switches it from positive to negative. But I'm more of a verbose coder, and you'll see a lot of this if then else, because I find it easier to read. And yes, I'm old school and a web developer, not a C+ developer. All right, so those are my excuses for my long-winded code. Okay, so once we make that step, then okay, we increment our servo step array so I can track what step in the process we're on. And that again is used for sequencing. So I can say, okay, 10 steps in from the right leg, move the left leg, or from the right femur, move the tibia, etc. Just gives us another way of tracking where the servo is moving and its progress. Okay, then it checks to see if it's done. So if the servo position, which we set up here when we moved it, is now at the target position, then it resets the steps to 0. It resets the speed back to its default speed if it's ramping. Okay, because when you end a ramp, it could be at a ramped speed and you don't want it to stay there. There is actually a bug in my servo ramp where if you interrupt a ramping operation, it will stop and all the servos will be set to that speed. And so that's something I have to fix. There is notes in the code about that. But yeah, so this will check if it was ramping, then it'll reset the ramp array as well as reset the default speed. And then, yeah, this I flagged as important because this is really why, not to get into this, but I did a hardware piece that monitors the amperage draw and will shut down the servos if it reaches a threshold. And this is why I did that, because yeah, sometimes your legs can crash into each other and lock up, and that's going to drive the servo amps through the roofs and heat up your servos and potentially burn them out. So this is very, very, very important if you're going to use the whole amperage circuit that I put together. Because this will check at this point, which is basically every little step along the way, and if it freezes up, it'll shut it down. Okay, and then if we were delaying, remember back up here at the beginning of this whole thing, the first thing we ask is if it's not delaying, then okay, we'll move it. But if it is set to delay, basically it just decrements that delay value by 1 and goes around the loop again. Okay, so that's essentially it to move one servo. It is a fairly straightforward and simple class. The real trick in it all is, like I talked about in the beginning, the servo speed, quote unquote, is really the delay time or the time between steps, time between increments, which again, I don't mess with the increment. In this case, we just go pulse at a time by you adjusting the speed. And that's, going to give us the smoothest movement possible too, right? If we bump that up to 5, you'll see your movement will be choppy as hell and you won't be happy. So that can probably be removed, that being said. But again, this class is adapted from my Hexapod project. And yeah, so the second part I'll just briefly look at, and we managed to keep this video under 20 minutes. So this next bit of code basically does the same as this first code, where it checks if you're ramping, makes the adjustments, and then it, checks for limitations, and then moves the servo, and then readjusts the arrays. Okay, this next block is very similar, but you'll notice it's regarding the sweeping movement. So I think this too is left over from the Hexapod project. If you want to move a servo from one place to another and then back again, you could still do that using my other code as well, but it would take 3 lines of code to do it. In the case of a sweep, it only takes 1 line now, because I can give it a start, end, and tell it to come back and forth, and tell it how many times to loop that, etc., which I explained in the previous video about the setup file. So I could eventually throw this away too. So I can clean up this code a lot, but who knows? Somebody out there might prefer to use the sweeping rather than stepping. So this essentially does exactly the same thing, but rather than use the same variable arrays to move for the movement steps, it's using the servo sweep stuff. So if we look at it quick, rather than say it is active servo, it's saying is active sweep. So if you set it to move, it's going to move it, but it also checks if that servo is active, not active, because that takes precedence over sweeping. So if you tell a servo to move and to sweep, well, your sweep is going to get ignored until the move is done. Okay, so again, the first thing it does is check if it's done with its moving. If it is, it sets it to inactive. And in this case, it also, if you have the servo switch enabled, which tells it to go back and forth, then it'll do that here. It'll switch direction. Okay. So here again, we check the state machine based on the servo speed for that servo, little debug code. And then you can see here now, rather than using servo delay and those other variables, I'm referring to the servo sweep array, which is your settings, where you basically tell the servo how to move all in one array setting. And then, yeah, it does the same thing, interpolates the ramp, and then it'll just move the servo by increment, and then changes direction if it needs to, if it's reached the end or beginning, and loop if it needs to, and that's basically it. So it does essentially the same thing, but it uses this servo sweep array for its parameters instead of the individual arrays. Okay, and I talked fast through that because I want to show one more thing. And I'm going to do some scrolling here because I don't really know where to show it, but I just want to show how I instantiate these moves. Again, there are a few different ways because I came up with the sequencing stuff as well. But here we can see this is one of the sequencing, and I think this is the only place this is used here in the demo. So this can probably be ripped out. But this checks the, oh, I'm sorry, that's the PS2 check. That's the remote. I should have collapsed all this before I get on this video, but here, so this is the human interface check, the sensor, PIR sensor. So when it detects somebody, I just have Nova do a little jolt, a little jump position, and that's here, right here. This is how I define it. So I just first determine what leg it is, and then I know where I want to position that leg through trial and error, obviously. But this is how you define that. So I'm telling it to set up moves for servo M, in this case, and then the first move will be this position. Okay, and the 0, I believe, is delay. So I could set up 1 move, 2 moves, and then I think there's a third, 3 moves. So here I'm setting up 3 moves per servo. So they'll do these in sequence to get into that position that I'm asking it to. Little complex to explain and to use, and I think that's why I don't use that method anywhere else. So that's the servo step moves array, which if we look back into the NovaSh file, the spacing is all messed up again, but aside from that, right here, it's this big empty array. So I've set it up that it could take, what do I have, 6 steps per servo. So basically you can sequence, but there's no delay or any fun stuff in that, unless I think that's what that 0 is for, where you can put a delay between them. But I probably shouldn't even explain that one because, like I said, it's only used there and then in my demo. So where else do we do some moving? This is all the sensor stuff, amperage check, battery check. Okay, here we go. So this is a simple one. Actually, this is a great explanation. So this InitHome I fire off in the beginning of the script when you boot the robot up so that it puts all the servos in their home position. Okay? And the way that I do that, and it sets all the defaults for the arrays, basically populates those arrays from the configuration file. So it'll go through and set all the sweeps to zeros because obviously we're not running any. It sets all the ramping to zeros, so that's all default. Sequence to zeros, delays, etc. The steps to 0, the back and forth switch to 0. It sets the speed to a factor of its current speed, and there's a default speed variable set up top. And then sets them all to inactive. Okay, and then it sets home. So if we scroll down and look at that function, what that does now is it's just going to iterate through our 12 servos and then set each one active and set each one's target to its home position. Okay, and then that state machine running that class that we just showed, the update function, will see, oh, okay, they set active to 1. What's the target position? And if servo position, current position, is not set to that, then it'll iterate and walk to that. Move towards that, I should say, not walk. Okay, so that's basically, this is the bare essential you need to moving a servo. So if you just want to test this, just go ahead and punch in your own little coordinate here. And you'll see throughout my code too, I do use the limits. So you could change this to limit. And then for minimum 0, for high 1, which will take it to its limit, right? And then often I'll say, well, let's go limit minus 50 pulses. So that's basically how I control and use that class. Those are the two absolute required variables that you would need to set, the active and target. And then, like I said, the class will pick that up and move as you asked it to. Okay, so I'm going to call it quits there. If you do, start going down here into my functions that move. So here's that demo function I was talking about. Yes, this uses the delay sequence arrays, but again, that's the only thing that uses it. Here's a simple set stay, which basically homes the servos. I probably could have just ran the homing here, but this is a cleaner way of doing it. So again, I'm setting everything to default, making sure it's not sweeping by setting that to 0. Then I set it active, give it a target position of its home. Here I'm actually fixing the speed as well at 10. And then if it's a tibia, I actually move those a little faster, which makes the motion much smoother going into its home position, so it won't topple over. And that's the beauty of using these arrays, is you can make these little adjustments depending on the leg, the motor, the position, what have you. You can change one little setting of each individual motor if you want to get that granular. In the case of a walking pattern, you have to, at least in pairs, right? Because they're not moving in sync. So, as an example. All right, so yeah, here we go again. This is a sit function, so you can see this is a bit more now. And this is the last one I'll review, and then we'll call it a day. So in this case, I'm actually referring to the specific servos that I want to move, whereas in the case of this function here, I'm just iterating through all of them, and then yes, for tibias, I'm making this one extra little change. I have functions down below that check is tibia, is femur, is front, and then is left or right, and with those you can determine what leg you're dealing with. But in this case, again, I decided to puppeteer this movement, basically, and then define exactly how each motor moves or each joint. Okay, so real quick, I set each, you can see these are all C's, so these are all 4 coaxes. I set them all active, set all their speed to 10, and then set their target positions to home. And yes, I could have just done a for loop like that, so Please don't bust my ass about my coding. It does need cleaning. I just find that when you're sequencing a step out like this and playing with and adjusting what parameters you want to use, it's better to do it like this first, because I may realize, oh, shoot, the left coax, I want to adjust a little bit, and then I'd be able to do this easier than if I was stuck in a for loop. So yes, this is probably the third time I've said it. My code can definitely stand to be cleaned up a bit. Okay, and then I set all the tibias, oh, here we go, just the two front tibias, you can see FTs to move, and again at speed 10, and this time to their minimum limits. And then I set the right tibias to move to their maximum limits. Okay, and then the femurs, these are the rear femurs. See, you can see here that I do just a little math because I didn't quite want it to go to its minimum limit. I wanted to pull it in a little bit more from there, so that's what I just minus 30. And these numbers are the ones that you'll have to play with. You know, that's what it comes down to, positioning and how aesthetically it looks as it's moving, etc. Same thing with speed. And that's, again, I think I said this before, that the beauty of using these arrays is now I can set the femurs and tibias to move at a different speed so that they'll arrive at the same place at the same time, kind of thing. Now, side note, if I was a mathematician and wrote true good kinematics functionality for this, none of this would be necessary. Apparently, I'm not a true believer in the whole kinematics thing right now, to be honest with you. It is great and it looks wonderful, but my question is, when it comes to something like this, where it sets sit, basically moves her into a position where she is in a sitting position like that I like and works well. How do you do that with kinematics is my first question. So it's probably just as long-winded as this. That's why I'm still torn on if I'm going to take this project in that direction or not. Okay, so yeah, I set the femurs here with just a little adjustments to their min and max values, and that's it. Then I reset the delay state machine. In this case, I didn't have to do that because these don't have any delays. But that's it. The state machine now will pick up all these active servos and move them all at once. Since this is just a repositioning, in this case, I'm okay with that, where it's going to fire them all at once and move them to those positions. But that is the reason for, like I explained, the slight adjustments in speeds here. So that even though they're all moving at once, some may have more ways to travel, but if that's the case, then I give it a little more speed, which will slow it down. So that's one other thing that I should explain that may get confusing. Because I mentioned this in the beginning, speed is really time, the increment time. Higher speed is a slower time, therefore a slower movement. So keep that in mind. It may get confusing again, but once you grasp that concept, to be honest, I probably should have called this servo increment instead of speed, and that might have made more sense. But the higher the number, the slower she's going to move, that motor. So keep that in mind. So in this case, the femurs will move a little slower than the rest of the motors because they're all set to 10. Okay, so then, yeah. All I have to do now is call this function, and it'll fire off that class to set all of these motors to these positions, which basically puts her into a sitting position. So as you go through the code, you'll see I have a dozen or so of these functions. So this one sets her to crouch position, sets to lay position, sets to a kneel position. You'll see a bunch of those. And then I have some actual movement classes where some of them use that sweep function that I showed and that its array to set them up. And then I got tired of using that and came up with a sequencing way of scripting them, which I think I like the best. So this is probably the method that I'm going to stick with. As you can see, it's much cleaner and prettier and easier to understand once you go look at this function, which handles all the population of the arrays and then executing them. Basically moves all of this code into a sub-function that you don't have to worry about. Okay, so yeah, you can go through this and you'll see some use the sweep arrays, some don't, some take the long-winded approach, or some use this updated sequencer. I think some even do a collaboration of multiple ways. See if I can find one of those for you quickly, and then we'll call it a day. So here's one. This one uses the servo step moves array to populate the moves ahead of time. And then it uses the sweep array to execute the moves. And then within here, I'm tracking the position of each servo and knowing when to fire the next one. That's why all this if move steps. So it checks to see how far along the previous motor is, and it'll move accordingly. All right, so there's a lot more to this code that I'm not going to get into because I'm just noticing I use the speed factor in here and other things that if you have trouble reading through the code and understanding the variables and how they're used, feel free, please, to ask in the comments. And let's try and keep it all in the comments of this video so that way when I answer, other people may read it and answer their own questions too. I'm here to help everybody, so yeah. That's about it. Let's wrap it up for today. Thanks again for watching, and I'm always available for any assistance or questions.